When companies are looking to, adopt Rust into their stack, they're looking for developers that can work in Rust. So instead of just doing something on the side, there's a whole new industry about learning Rust, teaching Rust, how to, be a full-time developer in something else and like bring Rust into your organization. And I think like that is the magic of just open source in general, right? It's like you never know.
Hi, this is the G-Research Open Source Software Outreach Podcast, the GR-OSS OUT Podcast, where we get contributors from all over the open source world and talk to them about the real problems and issues that come up when you're developing open source. And we aren't going to leave out the gross parts. I'm your host, Jay Faulkner. Today, we've got a twofer as our guest, which is really exciting. We have Lori Lorusso and David Wood, both representing the ARM project. Lori, why don't you go ahead and introduce yourself? Tell us a little bit about what you do, where you work, and if you have a name or a handle that other people might know you as in the open source or Rust communities, please make sure to include that.
Sure. Just to clarify, we're representing the Rust project, and David works for ARM, just to throw that out there. So I am the director of outreach at the Rust Foundation. I've been there for, about 8 months now. It's been pretty awesome ride getting to work not only with the community of our members, but with the actual Rust project itself. And the foundation is separate from the project. We help steward the project. We do what we can to fundraise and make sure we keep the lights on, as well as we do RustConf and other community activities.
So I know that a lot of foundations, like I've been involved with the OpenInfra Foundation for a long time as an OpenStack contributor, and there's a little bit of weird like hierarchical nature that's gotten in there. Like we're in the Linux Foundation, and then there's the OpenInfra Foundation. Like, is the Rust Foundation independent, or are y'all kind of in one of those meta foundations?
So no, the Rust Foundation is completely independent, and we work with the Rust project. And one of the cool things is that we have what are called project directors, and David happens to be one. So these are 5 individuals that are in the Rust project that sit on the Rust Foundation board. So that's how we try and tie everything nice together.
Okay, awesome. Well, let's talk to David. David, why don't you tell same sort of questions? Give us a little bit of your history and open source and the Rust project, how folks might know you, and where you're working, what you're doing these days.
Yeah, I'm David. I contribute to Rust. I've been a Rust maintainer for coming on 8 years now, or maybe a little bit more than that now. I kind of started working on Rust compiler a long time ago, and now I do stuff kind of across the project, including, like Lori said, being a project director, which means I sort of represent the interests of all the Rust maintainers on the board of the Rust Foundation and make sure that the Rust Foundation is kind of behaving and keeping us honest. And so, I do that professionally at ARM, where we kind of want to make sure that the Rust support for ARM platforms is really good. It's an exciting project to work on. I think, Rust has a huge impact on the world, and more so all the time, and that's kind of what's stuck me to it. I think I don't know there's many other projects where the things I work on would make the difference that Rust is making.
Yeah, let's dig in on that a little bit. Like I know that most of us are going to kind of natively understand a little bit about Rust is and what it's about. But if we've got a listener out there who's been living under a rock for the last few years, why don't you maybe give a breakdown of what Rust is and like why you think it's meaningful to the larger technology community?
Yeah, so Rust is a systems programming language that was started by Mozilla, like 12, 13, 14 years ago, or something like that. It's kind of occupies the same niche as C and C++ do, but the crucial kind of differentiating factor is that Rust tries to be memory safe. So there's a whole kind of class of vulnerabilities that Rust programs, kind of, unless you do something very wrong, just don't have. And so that makes it a really, really good platform to build on for sort of the kind of foundational software that we all rely on every day. I think operating systems, kernels, databases, network services, the kind of really important stuff. And hopefully, if we've done our job right, the language is also really nice to use and performant. And so Rust is seeing lots of adoption. all across kind of our industry, and really kind of important foundational projects. We probably all interact with Rust every day without knowing it, whether that's in our phones or operating systems or maybe cars or when we're making network requests. And hopefully the more Rust that's out there, the less vulnerabilities there are, and the more safe kind of all the software we use is.
Yeah, on a previous episode, probably like 6 or 7 episodes ago, we had Alex Gaynor of the cryptography project on, and he explained a little bit about memory safety and what that means, where like you maybe allocate something that's 3 long and then you try to write 4 in there and use that extra bit at the end to go do nasty stuff. So can you help me understand how like Rust has been designed in such a way to kind of make this impossible, or at least maybe not set up to trip over quite as easily as with C or C++?
Yeah, so Rust's secret sauce is what we call the borrow checker. That is part of our kind of really strict compiler. And it basically means that whenever you make an allocation of some memory, the compiler tracks the lifetime of that allocation and will make sure that when the when you no longer need that allocation, that it gets deallocated automatically, and that you can't kind of use that afterwards. And we do bounds checking and all sorts of other things for spatial memory safety, and sort of and that requires some restrictions on the programs you can write. So Rust is slightly less expressive in that regard than other languages, but the trade-off is you get all this, really nice security properties. And so by accepting a couple limitations on sort of how you shape your program, you need to sort of let the compiler guide you and write it in a way that the compiler is quite happy with. But you can still write a lot with that. It's quite nice once you get used to it. Then what you get is a lot more guarantees, a lot more correctness, a lot more sort of confidence in what you've written as it is correct. Yeah.
So I know that I've seen Rust code with an unsafe keyword in it. Is that does that allow you to venture into those other places where maybe the Rust design isn't well suited to it, or are you still kind of limited even if you're turning off some of the safeties in Rust? Like, can you help me put some borders around that a little bit?
Yeah, absolutely. So unsafe doesn't disable any of our safety checks. It just gives you some new capabilities. It lets you do some things we normally wouldn't let you do, but we still check everything we were checking before. And the idea with unsafe is that you can sort of express some of the kind of really low level things that Rust just can't check, such as when you're interfacing with hardware directly, and we have just promised that this is what the hardware does when we do a certain thing, like write to a register or something. The compiler can't check that. We use unsafe to promise that you're doing the right things and you're upholding all of Rust guarantees. And then you can write a nice safe abstraction around that unsafe code that lets users interact with that unsafe code while upholding all of Rust's guarantees. And that technically means you can still have some memory safety problems, but when you do, they're from these really small isolated bits of code that are really easy to reason about and check and make sure that you're doing correctly. And we found that, and I can, all of our users have found, I think, that when you do that, when you build safe abstractions on sort of unsafe fundamentals, you can actually achieve, quite a lot of safety in your whole system.
Okay. So it was commented that Rust was started by Mozilla 12 to 13 years ago. Is there like an interesting story? And I'm curious if maybe Lori might know a little bit more about this, of like why, like what was the initial impetus at Rust, and like when did it start to grow outside of Mozilla? Because I mean, today Rust really is kind of I think there's a -RS version of every package created in the last 20 years. So it's gaining popularity, and I'm curious like how it escaped the lab there at Mozilla.
Yeah. I mean, Mozilla started Rust for Firefox. There were parts of their browser that they wanted to parallelize, and they tried to do it in their C++ code base and couldn't. They just found that they kept running into memory safety errors whenever they tried to rebuild this part of their system. And so they thought, and obviously, as a browser, it's a big attack surface. It's probably one of the more complicated bits of software that any of us have on our computers. So they really wanted to make that secure. They do a lot of work in that regard. Rust was sort of a research endeavor of theirs to try and make a language that would give them some of those properties. And people saw the promise in it. It became slightly larger over time, and being started being used all over the place. And then I think that's where the foundation starts picking up when it hit that kind of threshold.
Yeah, and so I know this isn't like the gross out moment, but with a lot of projects, sometimes there are inner workings that don't necessarily work out. And so the foundation was kind of sprung up from that sort of issue. And so we've been around for 5 years, and we have been stewarding the project since then, which has been great. And I think, I came to Rust when I worked for a different company, when memory safety became the thing, right? People love Rust as a language, but all of a sudden security now became an issue, and everyone was talking about like the executive order about, things moving forward had to be written in a memory safe language. So to David's point about all the different ways that you might be interacting with Rust and not know about it, the interoperability of Rust is huge. Taking your legacy code and modernizing it with Rust has been great. And so the foundation is here to bring more awareness into all of the different avenues that people might not know about Rust. Like you might come for the memory safety and you stay for the compiler, you stay for all of these other reasons. And like, there's so many things that you can do without having to rewrite, with just having to wrap and build on top of. So that's kind of where we're at, is like Rust has been listed as the most loved language. How do we make it into the most adopted language? How do we take it one step forward? We've got the Safety Critical Rust Consortium, which is working with all kinds of organizations to just do that, right? To make sure we hit a certain standard where you can have Rust operate in airplanes and cars and other vehicles and things like that, where safety is critical. So again, you come for the memory safety, but then you stay because of all the additional components that make Rust the strongest. Well, I am going to say it because I work for the foundation, the strongest programming language out there to get you to do what you need.
Yeah, that statement not endorsed by the Python developer hosting the show. But, one of the questions I wanted to ask, and I think this will have both maybe some technical and some community elements to it, is that one of the kind of things that's happening in Rust and with the Rust adoption is that we're seeing a lot of tools that maybe were written in other languages getting rewritten in Rust, sometimes with an idea of it being more secure, sometimes just because, if someone's going to do something fun in open source, you use the new fun thing to do it. So, I think about, for instance, the core utils replacement that Canonical's been working on. And like, I don't know how to ask this question right. I kind of just want to talk about it a little bit, but I'm wondering, like, in your like technical opinion as a Rust expert, like what should be the inflection point for when you have a tool like that and you go, the risk that the memory safety issues present maybe outweigh the risk of introducing like logic errors or things like where's that line? How do y'all approach that? And is that like a pattern that y'all approve of and endorse, or, how do you feel about that in general? I'm curious.
Yeah, I mean, I think those types of decisions are different for every project, right? It's an engineering decision that's based on trade-offs and what makes sense for your individual project. Different projects approach this differently, and one of the things that we see rewrites of projects is one approach people take, but also taking components that are particularly at risk. Maybe they process untrusted user input or things like that, and rewriting those places where there's historically been lots of vulnerabilities and focusing on those types of areas. And so we try and make sure that interoperability in our language between C or C++ or other languages is really strong, so that that's an easy thing for people to do. That's what people like Alex, your previous guest, did with the cryptography library in Python that's Rust underneath. And I think some of the data from people like Google on their vulnerability half-lives and stuff show that focusing on new code or really high impact areas is probably where you should really be focusing attention with Rust adoption, especially in large existing code bases. And then for new projects, Rust is a really good and sensible choice to build on. There's no right answer for those types of questions. It's definitely, Rust is no panacea, and it's not the choice you want to make for every project, but it's a really good choice for lots of projects, particularly if, security is something that you need to be thinking about, and increasingly for us, that's a lot of us.
And I think too, like now that Rust has been accepted into the Linux kernel and there's groups like Rust for Linux and Rust for Python, like you can see that it's not like, as I might have said earlier, the best language, but there is that ability to work together from the community standpoint, right? Like we've got a Rust for Linux group within our Zulip chat, right, where they're working together on solving these issues. And I think, mentioning Ubuntu, like Canonical, they just became a member of the foundation. So they're even closer to the project and to like how things are working together and how we can progress forward. And I think that's something that's really important too, is to talk about the sustainability of the language. And to do that, you need funding. And so, knowing that more companies are coming on board and saying, yes, not only do we want to use Rust as part of our infrastructure, we want to support the community by becoming a member of a foundation. I think that's really important. So again, like having this cross-community collaboration, making adoption and interoperability better because you've got the people on the ground working to make this happen so that others can then pick up and, stand on their shoulders and build new cool things is really awesome.
Yeah, I'm gonna definitely dig in on one of those things there because you touched. I am an incrementalist. I'm definitely the type of person who sort of feels like, why throw out all the mistakes you're so familiar with to just have a whole new batch to learn? Like that's sort of how I think of the replacement. So I like that. But I really liked what y'all said, and I don't know if this is an exact quote or if it's just a JFI'd version of what y'all were saying, but interoperability is what's really enabling incremental adoption. And incremental adoption seems to be what's being preached. New projects. Rust is a good choice. Existing projects. Is there a way for Rust to incrementally become a part of that? And I think the kernel already had that written down as like a good success story for this sort of thing of where you take something as in use as the kernel and you're able to find a niche where like now you have, a bunch of geeks who want to have Linux running on their Mac sort of piloting the Rust in the kernel. That's probably going to be powering device drivers in the servers that the clouds I work on are going to be running in a few years too. So it's always exciting to see that. And one of the things that we see in open source a lot is like that evolution over time. So I'm curious from like a Rust perspective. It's been around for 12 or 13 years, but I definitely think like maybe only in the most recent 5 years, perhaps the foundation has something to do with this. Has it been as much in the internet psyche as it is? So I'm wondering like what's that evolution that it's gone through, right? Like there's a lot of history before a lot of people start thinking about it. Now we've got a lot of history after it. So how has Rust itself evolved over time? And are some of the things like the interoperability reflected in lessons learned? Or I'm going to be honest, I don't know a lot about starting a language from scratch. So maybe it's completely something different. I'm just curious.
No, I mean, the language has definitely grown a lot. I mean, I think back 8 years when I started working on Rust, I could see the promise, but it was, the idea that they'd be able to do it professionally, never mind that it would be deployed in so many places you'd never have thought. And so, yeah, I mean, the language is definitely, we're fortunate in that because, Rust, like I said, it was kind of built to be a component of, or built to power the components of Mozilla. Interoperability was a first class thing from the start because it had to be part of Firefox, and then we're never going to rewrite all of Firefox. And so we've always had a really strong C interop story. And over the years, we've built up on that to get better interop stories, things like WASM for C++, which the foundation have an initiative to work on, and obviously with Python, with things like Pyo3 and the Rust for C Python people. So, interoperability has been a really key thing, from the start, I think. And definitely, we're now getting to the point where the language has been growing for so long. There's so many new use cases that we're still learning about that we need to address and adopt to help spur that adoption, like in safety critical industries where the needs are quite different. And how we sort of continue to evolve the language while maintaining backwards compatibility and how that looks is starting to become a much bigger factor in all of this as well. So yeah, it's definitely a really interesting. I think every language is probably different in how it grows over time, but yeah.
So I'm going to give you an envelope-shaped time machine to send one note back in time to yourself 8 years ago when you started working on Rust to like prevent a mistake, to change a design decision before it's baked into the API. What do you put in the envelope?
Oh, I don't know. I think I would probably have thought about some of a bunch of our current work is looking at what like effect systems look like in the Rust compiler and the Rust language. And a lot of our core parts of the compiler are built around the way things worked a while ago. And it would be nice to have thought about maybe some of the features we might be looking at designing now. And when we were building that type system so many years ago, so that we don't have to rebuild it now like we are.
there's no one to hate more than the previous you that wrote the code that you're changing today. That
Exactly. Yeah.
So, Lori, I think you had like a foundation perspective on that question, though. I sort of cut you off because I wanted to ask David about the back end time, but I want to make sure you get a chance to address that because I know there's two sides to that coin.
Well, I think when we're talking about the interoperability of Rust and the adoption, I mean, David said it, right? He worked on it like for fun, and now he gets to do it as a profession, like as part of his job. Like his job is to work in Rust. And I think that has been key to us growing the language, is that when companies are looking to, adopt Rust into their stack, they're looking for developers that can work in Rust. So instead of just doing something on the side, there's a whole new industry about learning Rust, teaching Rust, how to, be a full-time developer in something else and like bring Rust into your organization. And I think like that is the magic of just open source in general, right? Is like you never know when something that could be just a pastime can turn into your actual profession. And I think that's where we see, again, Rust being like the most loved language to now being a career path for people, which is great. And, we're really, the more adoption, the more jobs, and like the more we can continue to spur that on, the more people can work in the project, and so not just use Rust as a tool, but be a part of creating the tool itself.
So, and that says, I mean, I work on Gen 2, so like I'm aiming at myself a little bit here, but we like to romanticize this idea of volunteer open source, right? Of where it's people giving their time, working on their weekends, making this awesome thing in GitHub. But for me, and maybe this is because, I'm sitting in a house that's paid for by open source, I think professional open source is a super important part of the ecosystem. Like in a lot of ways, the professionals are the ones laying down some of the foundation that the hobby stuff gets to get built on. And even though we do see that transition, like I think sometimes it turns people off a little bit to the idea of like seeing a project corporatized, but I get excited for exactly the reason you're pointing out, because that means that my friends and people I know who work in this technology are going to all have jobs. They're going to get the support they need. They're going to not necessarily have to, maybe drown in the onslaught of AI slop. Maybe they get some help from a foundation to deal through stuff like that. And so I actually hold a particular love for that. I mean, that's corporate open source is definitely a topic that happens a lot on this podcast because we have a lot of folks on here who are professional open source developers. And I really embrace that. And I think that it's a really positive effect that foundations have on the ecosystem that is really easy to overlook. So like if I were to ask you, Lori, like, is there something in there that is neat for the Rust Foundation that maybe y'all are doing that people aren't thinking of when they're thinking of the Rust Foundation? Like, are y'all behind the scenes helping, keep infrastructure running, or what exactly do y'all do other than just, keeping the community happy and doing marketing?
So the Rust Foundation does employ some maintainers. We've got infrastructure maintainers. We've got security engineers on our team. And one of the things that we started last year and we're working diligently with the project on is the Rust Foundation Maintainers Fund. So as much as we'd love to continue to have more employees at the foundation, what we're trying to do is also support those that do not work for the foundation, but are maintainers within the project. So I implore anyone that is looking to give back to Rust to look up our Rust Foundation Maintainers Fund and make a donation. You can do it through our GitHub. You can contact us. But that's one of the ways that we're trying to support those that can't get a job in the corporate world right now, but are trying to build this language, maintain this language, and would love to do it with the support of, dollars and not just a pat on the back. But again, donating to the foundation and being a member of the foundation, those dollars do directly go to supporting the project. Yes, we keep the lights on. Yes, we have infrastructure. We are working on more partnerships to make sure that we have cloud credits and we've got CI credits and we've got all of that to give back to the project so that they can continue to not just maintain Rust, but can experiment, can see what's out there, what's new, what can they do to build. Another thing that we're trying to do is to get more of our members involved with actually development within the project, right? Like, how can we see from the needs of the project and bring those needs to the table of our foundation members and say, you know, as much as we love that you're members, can you also donate some development time to the compiler team, to the Rust Up team, to the formatting team? Like, how can you help us continue to make this move forward? You know, it's not just about building your features, it's making sure that the project can keep the lights on, can keep the wheels spinning, can deal with what's happening in terms of lots of contributions coming in that may or may not be from humans. We don't know. But like, how can we increase this life cycle, right? Because again, it's not free as in beer. It's free as in choice. And the freedom of choice is if you choose to use Rust, you should support it either with your development, with your dollars, you know, with your hard work as you use that to build what you're building.
Yeah, and we'll make sure there's a link to that Rust Maintainers Fund, the Rust Foundation Maintainers Fund. We'll have a link to that in the podcast description in your podcast app or in the video description if you're watching us on YouTube. Obviously, G Research is a big supporter of open source, and very glad to hope that some people will point that stuff in the direction of the foundation. But one of the things we always like to talk about here is, you know, it's important to me not to gloss over the hard parts, because we know that like getting this stuff done every day is tough. There's hard decisions. There's tough situations. And this time maybe we get to do a double up, right? We usually get one gross moment per show, but I've got two people, so I'm going to hit you each up for one. Can maybe you tell me about a gross moment that you've had where something came up, you didn't know how you're going to defeat it, and then talk about how you got over that and the outcome being good, just in case there's someone out there today struggling who needs to hear the success story.
Let me embarrass myself first. Let me go first. So as we know, as you've heard this entire conversation, I am not technical, and I worked for a previous company that was an open source database company, and we were creating a security layer to a database we were working on. So I poked and prodded my team and said, "Hey, we need to submit to this security conference, and not just database conferences. Like, we need to get in front of people that are going to like really be excited about this." We submitted a talk, it got waitlisted, and then 2 weeks before the conference, they said, "Oh, you're accepted." And my co-presenter, I was going to do the fluff, he was going to do the technical stuff, had made plans and was not going to be with me at the conference. Fun fact, this is on YouTube, so you can Google Sauce Fusion and my name, and you will also get to watch this last 5 minutes of that talk, me dying on stage. So the first thing I said when I started my talk was, I know that you guys came for a technical talk, but as you can see, my presenter is not with me on stage. So we're just going to go through this, and I'm going to do my best to knock this out, and questions held at the end. And I'll give you the information you need to contact the people that can give you the answers. When I got to the Q&A, knowing that I'm not technical, I was hoping I could just say thank you and do you have any questions? Oh no, great, and then walk off the stage. That did not happen. I got a series of technical questions, not just one, not just two, but a plethora of people asking me highly technical questions to where the audience was just talking amongst themselves and I was just stuck on stage. There's a point in the video you can see me just give up. Just, you know, there was nothing that I could say to make this end. It's one of those things where it's like the worst thing that could happen to you happened, and it did. I survived by just pivoting to open source and the value of connectivity and asking questions and having discussions and how great it is to have a seat at the table. But inside I was dying. And at the end of it, to make my day better, I went straight to the bar and had a drink. It might have been 10 a.m. It's okay. But that is my gross out moment, is being a non-technical person, giving a technical presentation and getting blasted with lots of technical questions I could not answer.
I've not watched the video, so like I don't have actual knowledge, but when I hear a story like that, what I hear is that someone who's an expert at creating community and discussion did that at the talk, right? Like, that's, to me, if I gave a talk, I'll tell you my own little gross moment around the talk. Like, I've given a talk to 4 people in a conference room before. I had the post-lunch slot at a conference that didn't cater lunch, and there weren't enough restaurants around. And so it's like, I think that there are worse fates than having an engaged audience who are answering their own questions. That actually sounds like maybe a person who is good at bringing people together and encouraging discussion did that. So I'm curious if people who were in that room that day think of that as gross of a moment as you do. But, we're always harder on ourselves than anyone else ever could be, right?
I appreciate you, Jay. Thank you.
All right. Well, David, what about you? Do you have a gross
Yeah,
moment for us?
I don't know that my story can stand up to Laurie's experience, but there's a feature we've been working on for a long time in Rust called buildstd. Rust ships a pre-compiled standard library, and this lets you rebuild it so that you can use different compiler flags and things like that. It unblocks a bunch of work in Rust that needs you to have matching flags across your whole build. And we've been trying to add that. Well, people have wanted that in Rust for a long time. The first request for it must have been 3-4 weeks after Rust hit 1.0. So it's been coming on 11 years now. And it's something we've been trying to work on at ARM. And when we first tried to start doing that, we sort of, the people at the time, weren't as familiar with the Rust community. We went on stream, found some issues, thought, okay, we'll solve these issues. We'll file some PRs to close these, all's well. But then obviously what it turned out was that, if you were in the project, you kind of knew that those issues weren't quite up to date. They maybe were in declaration of intent 5 years earlier, but not quite, what we needed. That's kind of unspoken knowledge that that's not the way to go. We eventually got things back on track by taking a more holistic view of the whole process and trying to solve the problem kind of as a overall design rather than trying to solve these individual issues. And that worked for a while. We were making good progress. But what it turned out ended up being the case was that every step we made forward, that we were actually frustrating some of the contributors we were working with who had quite different expectations around how our communication should be and how often we should be looping them in and sort of what that looks like for that team in the project. One of the reasons buildstd has been sitting for 11 years is that it spans so many parts of the Rust project that no one individual owns it, or no one team or group owns it. And so it falls through the cracks because it's nobody's responsibility, really, it's everyone's. And all that sort of boiled over around a year ago now at one of our in-person meetups, and we might have a lot of conversations and get everyone back on the same page and get everyone aligned again. And ultimately we did that and it worked out, and we've had some successes recently with this project, and we've published or had accepted some RFCs proposing the feature that are 25,000 odd words collected. So we finally made it, but it's kind of a difficult and long process to kind of get just to this point to highlight where the project needs to improve when it comes to how clear is the status of things for external contributors, how the structure of the project can mean things fall through the gaps, how the culture in different parts of the project can be really different from what I'm used to, and how I may not have expected that, and we have to accommodate those types of things. Lots of different lessons learned, but ultimately ends up with a feature that was highly in demand. We're now getting there with it. So,
well, I think many of us in the open source world have probably been on both sides of that, right? Like we've been the person who was excluded by accident or intention, and we've been the people who have excluded by accident or by intention. And I know that in the moments where that's come up, where I've been the perpetrator, it always just hits with like an, oh no, like that's, I don't think, I always like to try to think that we can assume good intentions in open source interactions, especially like, we talked about the value of corporate open source. The fact that like all of us are professional enough to be employed at a job doing open source means that we're going to treat each other with a baseline of professional respect. You don't always get that in all communities. You get in a lot, but not all of them. So that was interesting. I am curious though, I'm obviously I'm a Gentoo guy. I'm doing this call from a Gentoo Linux install. Is that project the reason why Rust flags is now in my make.conf and I can set custom compiler flags, or is this something entirely different?
No, that's something entirely different. Rust flags is an escape hatch that we have. This is part of our build system primarily, and it lets you just recompile the standard library with different configurations. Normally we ship a standard library, and this will mean we don't have to, well, we'll continue to do that, but you don't have to use it.
Okay, well, that's really neat. I don't know enough about Rust to know how that correlates. And I could probably, like, honestly, a topic I avoided in this podcast because I didn't think we'd have time is I'm always really curious about why the shared library model versus the vendor stuff model. And I suspect there's stuff there, but we've got to leave something on the table to talk about maybe next time, because I know that Rust is going to be around for a long time, and I hope that y'all have good success with it. I just want to thank you so much, Lori and David, for taking time out of your day for being a guest on the Gross Out Podcast. We really appreciate it. On behalf of myself, Jay Faulkner, G Research Open Source Software, our producer Ben, Lori, and David, thank you so much for attending, listening to our podcast, being involved. Please do check out the description. We'll have links to everything that Lori and David is involved in as mentioned today there. Please like, subscribe, and review in your favorite podcast app. And thank you again so much for your time and being a listener here. I'm Jay Faulkner. That's the Gross Out Podcast, and we're out. Thank you.